then I'll look at the area. The area is equal to the change in position. Since the car started at 0, the change in position is just equal to R2. This is a triangle, so this is 1/2 the base, which is T2, times the height, which is V2C. I'm going to need to use this later also. And I can't do anything more with these two equations now because this has 2 unknowns and this has 3 unknowns. So I have 2 equations and 3 unknowns. So now I got to look at the truck. Okay, so for the truck, I look at the slope. And for the slope, the acceleration for the car is 1. It's 1.0. Let's just call it 1. Then I have the change in velocity, which is final velocity minus initial velocity. Final velocity is v2t minus initial velocity. Initial velocity is 16, so that's going to be v2t plus 16. Divided by change in time, which is t2. So let's here also multiply both sides by t2 and simplify a little bit. So we have v2t plus 16, and I'm going to have to use this later also. Okay, now because we didn't include the units, it may look a little funny because here it looks like t2 times 2 is equal to v2c, but we should have units for this, so the units for v2 and t2 are different. And if we brought this v2 over to the other side, it would look like we're subtracting velocity from time, but the units are different because this one actually had units of meters per second squared. Okay, so we looked at the slope for the truck. Now we got to look at the area. And for this, I'm going to do the average velocity. And the other problem where I use the average velocity, I didn't really explain how I found it because it was easy enough to do with the numbers. But if you're looking for the average velocity, you add your 2 velocities together. So that's v2t plus negative 16, so let's say minus 16, divided by 2. So for the average, you add the 2 velocities together and divide by 2. Then if I look at the area that I have for this rectangle here, that would be the average velocity. So v2t minus 16 divided by 2, that's my average velocity, times t2. Okay, now let me think about this a little. The area here is negative because it's underneath the x-axis here, but v2t is also supposed to be negative. And so I have negative something minus 16, so this whole thing is going to be negative. So this is going to turn out to be negative. So this is equal to delta R12, which should also be negative. Delta R12 for the truck is R2 minus R1. Is R2 minus R1, so that's R2 minus 350, and this will be negative also because if this is the positive direction, the car starts at 350, ends at a positive position. This is 0, so it ends over here, which is a positive position but less than 350, so this is negative. This will also turn out negative, assuming that the velocity of the truck never reaches 0. Area is equal to change in position, so that's delta R12 or R2 minus 350, and that's our last equation. I'd like to simplify this a little bit also, so let's bring the 350 over to the other side, and I don't know that it's really going to help in the long run, but let's divide by t2 and let's all divide by 2 and also we'll distribute the t2. So this is 1/2 v2t times t2 minus 16 divided by 2 is 8. We'll distribute the t2 there. Okay, so now we have 4 equations, 4 unknowns, and we can start solving for things. My suggestion here is always to keep t2, so we're going to try and get rid of everything else and keep the t2. Here I have v2c, and I have a v2c here, so I'm going to take this and put it into my v2c here, and that gives me r2 is equal to 1/2 times t2, then putting the t2 into v2c, that's 2 times t2, which ends up being just a t2 squared. Now I'm going to do something similar over here, and I have my 2 equations here. I want to keep the t2, so I don't actually want to substitute this in here because I want to keep the t2. If I do that, it will be getting rid of the t2. So we'll rewrite this and say v2t is equal to t2 minus 16, and then take this and put it in for v2 here, and that gives us r2 equal to 350 plus 1/2 v2t is t2 minus 16. That's the v2t, and this is times t2 minus 8 times t2. Okay, now we'll distribute the 1/2 and the t2. So this is 1/2 times t2 squared. Distributing the 1/2 makes this minus 8 times t2, so that's a minus 8 times t2, and we already have a minus 8 times t2. So this whole thing now is 350 plus 1/2 t2 squared minus 16 t2. And this was equal to r2. So I got this and this, and the left-hand side of this equation is r2, the left-hand side of this equation is r2. So if r2 is equal to this, t2 squared, and r2 is equal to this, then the right-hand side of this equation must be equal to the right-hand side of this equation. So we'll put these two together, and we get r2 is equal to t2 squared from this equation, and from this equation 350 plus 1/2 t2 squared minus 16 times t2. Okay, and then I'm going to ignore the r2. Now, this equation, that's not supposed to be a t2 squared, that's just minus 16 t2. So this equation has a term without t2, term with t2, and a term with t2 squared. This is a quadratic equation which can be solved using the quadratic formula.